Hello, everybody, and welcome to our live cast about troubleshooting your SaaS applications and keeping your ISPs honest. I'm Kevin Sparenberg, and with me we have Mike.
Hi, Mike Driscoll.
Hey, so we've been working with this for a while. We're going to go ahead in this particular series. We're going to touch on some things you probably know, but maybe don't know all the details. Maybe you need a little bit more information, or maybe, and we see this all the time, you have the products, you're using the products, but you didn't know you had these features. So that's kind of where we're diving in these live cast series. Want to make sure that we cover all the things, but I don't want to spend a ton of time on conversation. All right, anything in setup that we need to accomplish?
No, I was just going to say that is a pretty common comment I hear from a lot of the customers we talk to, is not knowing, especially NetPath, that this actually exists, because a lot of people do find it to be a lifesaver in either proving it's not the network, or at least not your network.
Yes, that is probably more accurate. And so, warning everyone in advance, we have a poll at the end of the session. We're going to have a survey at the end of the session. We'll remind you when we get closer to those. I say we just dig right in.
Sure.
So there's a couple benefits of NetPath. We're going to talk through them real fast, but I think it's better to show these kinds of things because I'm a visual learner in this space. And realistically for me, understanding that I get control, visibility, and insights on the network that I don't own and operate is incredibly important. But these are bullet points to me.
Right.
I mean, I like them. They're succinct, but I want to see the thing. So should we show the thing?
We should.
Okay, let's show the thing. So earlier today, we're going through and we're talking about what we're going to show, and we came across actually a new NetPath for us that we hadn't seen someone build before. And it was down here. And this is your NetPath screen. If you haven't seen this, it's all accessible through My Dashboards, Network, NetPath Services. If you're running NPM, Network Performance Monitor, from the last 2.5 years, 3 years?
Probably 3 or maybe even more.
Yeah, so if you're on one of the recent revisions, you've got this. It's actually amazing. So we're just going to bring up one as an example. Google ships out of the box, so you're already monitoring whether you know it or not. But I want to talk about what we're actually seeing here. And it's going to be a little tricky just because of the size of it. So if you're having trouble seeing it on your little screen, there should be a show full screen option. So we're going to start off with where we sourced this from. And most people, when they initially see something like this, what's the first comment you hear?
What am I looking at?
Yeah, and the following one is always something along the lines of, I already have this, it's called Traceroute.
I like to think of this as more like Traceroute on steroids, or version 3.0, something like that.
Yeah, well, I mean, that's the thing. Traceroute was brilliant when networks were flat, because it literally just cared about next hop, but that's not the way real networks work anymore. So what we're actually seeing here is traffic to a DNS name on port 80. Realistically, you'll probably be running on port 443 because not a lot of people run on 80, but if this is how the service is defined, this is how the service is defined. And we're starting off somewhere for a machine that we own. We only need to own the source. We do not need to own the destination. And the source is like a Windows 2016 core or better. It's really small footprint. So you can put them anywhere, and I encourage you to put them everywhere, actually.
And we'll install one of these NetPath probes by default on your SolarWinds server. But if you want to get perspective from another location, maybe you've got some end users out at an office, you want to see what their paths look like, you could put a probe machine out there as well.
You can even put them on their endpoints, the actual Windows desktop machines. It will run. Actually, it runs pretty well and is very low lift. And it's actually really interesting to see when people are on and not on the VPN. We don't have as an example of that, but understanding the path across even your VPN, even though it's all obfuscated from that VPN tunneling, understanding that connection's happening.
And then all you really need, like he said, is a source, and then what's your destination? So DNS name or IP address, and a TCP port. That's the part that's key, that I think takes it to that next level, because we're not just looking at, can I get a ping across there, but how about the service my users are leveraging? So port 80 for a website, or 443, or maybe you want to test your DNS out to whoever your DNS provider is.
Assuming you're using TCP DNS.
That's true.
Yes. But it's also, I've seen people use this where they don't actually own any kind of servers in their branch offices, but they do own the routers or the endpoints. And if they own the routers and endpoints, they probably have SSH turned on, and it may not be running on default port 22, but if it is, you can literally put the IP address in here, port 22, and see the trace from your main data center to all your branch locations. So what we're actually seeing here is this is our source. You can see here we got these cute little icons. That means these are part of our network. We've got little bullets here indicating these are our interfaces. But because this is integrated with the rest of the solution, we get a lot more detail. So
yeah, so these nodes in particular are being monitored by NPM. We're collecting some data about the interfaces on them, about the routing and packet loss and whatnot. So we have some additional statistics here that we see because we're monitoring. And then as he goes a little bit further to the right on this screen, we'll start getting into more of the either devices outside of our network or devices that we're not monitoring. So you might have things like firewalls in here that for whatever reason you're not monitoring. Maybe they're owned by another team.
This is actually a really good example of that. You'll see something similar to this, and this is because this is a completely pass-through firewall. It's transparent. So NetPath knows a hop is taking place, and it shows you that, but you have zero insight inside of it. And this is intentional. This is the way the firewalls are designed. But then when you actually hit your edge, that's where you kind of get interesting. So you'll see here, I clicked on Charter Communications and it broke it out into these 4 areas. Now, these are the routers. They may actually be switches that do routing, but these are the devices your traffic is going through from that source to that destination. And what's interesting here is if this were internal gear, I'd know the name, I'd know the IP address, I'd probably know what team it is, I know what office it's in, I know who to contact. Well, we're going to give you that anyway. So if you look over here on the right, if I select one of these, we're actually going to tell you that this is owned by Charter. The prefix for this particular device will give you the AS number. These are all publicly available from the, I think it's the ARIN database.
ARIN, correct.
Yeah, so we'll get this all from the ARIN database, and the phone number and how to contact them if they have any problems. So in this case, Charter is the first hop. So Charter is the one you're probably paying dollars to and saying, I want internet. So if you have a problem in their network, you can call them. But what happens when we go a little further out? So I'm going to try to zoom out a little bit here. So let's say we're having a problem. Now, here we've got a problem, the tail end. But before we get all the way to the end, how about this? Well, there's a problem here. Well, that's not Charter's. That's Microsoft. Microsoft happens to own this router. So if I'm having a problem and I see something within their cloud, and all of their cloud, at least that I've seen, has all been MSN.net. That's how they've labeled all of their internal routing. So it's really easy to kind of just say, this is a cloud-based problem. Let's go ahead and contact the cloud provider and say, hey, I can't get from this location to this, and it looks like traffic is dropping right about here.
I think you said the magic word too.
Which is?
So cloud and SaaS. Those are the two that I think that really makes NetPath a valuable tool to you. Is we've all started outsourcing services to the cloud, putting things in a SaaS. The trade-off for that is we lose our visibility to some degree. We lose our control. So I no longer can just go walk in a data center and see what's going on with my server and see that Kevin unplugged a cable. Now it's farther past that. I need to go all the way out, in this case, to Azure and see that we have an issue. So it gives you some insight into those things that you typically wouldn't have insight into.
Yeah, and it's gaining visibility where you've previously been blind.
Yes.
And being able to do this on really any TCP service, because we don't care what the back end is. We don't care if port 80 is technically hosting an FTP service. As long as port 80 answers with some type of TCP handshake, we'll watch it. It's fine. Now, in this case, it looks like someone actually turned the server off because it's down. But the hop all the way through it is clean. So this tells me if someone in one of our branch offices calls and says, hey, I'm having a problem getting the tailwind, like, let me look. I look at this, network's clean all the way to the end. Oh, someone turned off the server or powered down the VM or shut down the cluster.
Since we're testing port 80, maybe they forced everything to 443 and they're no longer redirecting.
That's correct.
Because that's the other key thing about the port. We only care about a TCP port. We're not actually logging in. We're not trying to SSH into a device like you mentioned earlier. We're just making sure that port answers. So that's one of the cool things is it can literally be anything. You don't have to have credentials. You're just testing to see if it's live.
Yep. And one of the things that people, I think this is the one I want, So one of the things people say is like, this is complex, this is really tough to set up, there's a whole lot of steps involved, I'm sure I gotta open a million firewall ports, I gotta let this thing through, no. All of that is ridiculous because we needed this to be as simple and easy lift as possible. In fact, if we wanted to create a new service, it's create a service. Do you have something you want to watch? Because if not, I'm just going to put in something pseudo-random.
Go ahead. Let's go random. I think that works for us. And while he's kind of putting this in here, so he mentioned you don't really need to have anything set up on your environment. One of the key reasons for that is we are testing the same ports that your users are going to. So you likely already have that port allowed through your firewalls. The only thing you do have to make sure, and usually in most cases it's on by default, but our probe does need ICMP type 11 allowed through the firewall. Other than that, there's not really much we need as long as we can get to that target service.
Yeah, and that ICMP type is typically let through except for the most secure areas. So should be all right.
And that also could determine where you place your probe, because it could be you have your data center zones locked down and you're not going to be able to get to that user service, so you may have to either alter your firewall rules, not a good thing,
no.
Or place a probe in an area that already has access to what you're trying to test, like the end branch user location that I mentioned earlier.
Yeah, not necessarily within a specific DMZ area, but realistically, these probes are best served by being at the end user's location, not even like on a separate server subnet. If you can put it on the same subnet these people are on, so much better. So I'm just picking, I know it exists, an IP address, and it doesn't have a DNS name, so forgive me for that, and port 3389. Pretty sure I have that right?
Yeah, that's RDP, I believe.
Or maybe it's 58 something, I don't know. We'll figure it out. The whole idea is we want to check this out. And once I assign it, you'll probably only have this first one, which is your Orion server, which is fine. I can send it from other locations.
Because we already have those probes configured in our lab. But there was also, if you notice there was the option to create a new probe. So if you already have a Windows box out there that you wanted to leverage that on, you could run through that. It would install our agent and the NetPath plugins to allow you to do this.
Yeah, and that's it, we're done. Now we just have to wait for it to pull. And that normally takes about 10 minutes because it's not like, this is not a ping. This is a network, I don't want to say scan because it's not a scan, it's a network inquiry, I think is the best way.
There's a lot of hidden magic underneath the scenes. So if we were sitting there on that box that the probe was configured at, and we were to do a trace route out to the end point, and there are even ways to do a trace route where you're giving a TCP port, it would take one path. And it almost always would take that same path unless the path changed.
Yeah.
We do some things to the headers to try to force it to go additional paths or learn about additional paths. So it is much more complex than a standard trace route or a ping. And as he mentioned, the default polling interval is 10 minutes. Usually I tell people that 10 minutes is fine. Maybe you want to make it a little bit higher or lower in some cases, but 10's the default.
Yeah, if you're doing something like internal to internal, you could probably bring it down a little bit. But if you're hitting a SaaS app, 10, 15, even a half hour, depending on the frequency of use, is probably okay. We're going to leave this one, just like the cooking show, we're going to leave this one to bake a little bit, and we're going to talk about some other things that you get. So if we go, we're going to go ahead right back to NetPath services, and if you actually have additional modules, if you have the configuration module or you have the NetFlow module, we're going to surface information from those to you as well. If you don't have those, then these are quick things you can add to your existing, but I want to show the NetSuite one. I think this is probably the best example of our config change capture, right?
Yeah, and this is a really good example as well, because earlier I mentioned, it's not your network. Well, sometimes it can be.
Yeah, sometimes
this
you
is a good example of that.
Yeah, so this one is really simple as far as the way it's designed. So we're going from an internal server to an internal service. So this should be cut and dry, right? Well, it was.
Yeah, so especially since this one's not as expanded because it's not working here, I want to talk about a few other things we see on the screen. So you'll notice, starting at this Windows box on the left-hand side where we have our probe, we're actually going hop by hop. So we didn't really talk about this earlier, but it's measuring the latency for each step of those. So 10 milliseconds latency between our probe and the first hop in that. Then we have a couple of different paths. And you'll actually notice here, if you kind of think of how Google Maps works, the thickness of the path is how likely we are to take the traffic down that path. So a thicker path, think of it as your interstates. Then you might have thinner paths that are more of your side roads and whatnot. And if you actually hover over it like he's doing here, you'll see the transit likelihood. So basically it's saying there's a 12% chance we're going to take this path compared to if you hover over one of the other ones. And our likelihood is 45% chance we're going to take that path. And that's part of that magic I mentioned, so to speak, in how we alter the headers to try to figure out additional paths. And then you get to this big red blob here.
And
that kind of looks like a routing loop.
Yes, this is down. And here's the thing, and this is what, I think this is my favorite thing here. It's in plain language.
Yes.
Because even if you are new to networking, or new to network monitoring, I guess, understanding that the BGP establishment is a status of 4 open, what? You know, when you're new, that doesn't mean anything. But when you see this and it says, this edge contains a potential routing loop, well, that makes sense. So the real question is when did this happen and how do I fix it?
And that's the point we didn't really talk about earlier, but if you look at the bottom of the screen here, you can see the path history. So that's important. Right now, we're looking at now. Well, when will then be now? We can actually go back in time. Thank you. I'm glad that didn't just get
it did not go over my head.
But we can go back in time and, okay, first of all, see what it looks like when it's working. So now we can see, and this was sourced from a Brno office, so we're seeing it go through T-Mobile Czech Republic and XO Communication, and finally to the target we're testing, which in this case is NetSuite 443. But let's go to the first failure. So the first time we detected the failure was around 10 a.m. And there's a nice little pop-up there that says config change. So we can actually highlight that. And this is coming from that Network Configuration Manager. So one of the features of Network Configuration Manager is the ability to back up configurations, but it also can do something called real-time change detection. So by default, we typically back up a config every night at 2 a.m. But you can also set the devices to say anytime there's a config change, send the SolarWinds server either a SNMP trap message or a syslog message, and we can see that message come in, we know that it's regarding a config change, and it basically kicks off an action for us to go grab a backup.
For that one device.
For that one device at that time. Go grab me the new config. Let's see what happened.
Yeah, so for Cisco, that's anytime you type exit or Control-Z out of the conf thing. It's real. It's not like constant we're pulling. It's when the config is basically pseudo-locked.
Correct. And the language will vary on some other devices. So this doesn't necessarily tell you what your smoking gun is, but we can go see what changed here. So as he scrolls through this, we'll get to a point and it'll highlight for us what had changed, and we can find out, what happened. Was this something that broke? Nope. Somebody changed a routing statement. So in this case,
even better, it's green. This was added.
Correct. Somebody added it. Yeah. So we shot ourselves in the foot.
Yeah. Whoops.
So that whole it's not the network or not your network. Well, in this case, it's the network, and we're going to blame that guy over there, Bob.
Yeah. It'll be someone else's problem. But if you have this, then you can just copy this to the clipboard, connect to that machine, probably put a no in front of it, hit enter, and you're probably okay. In this case.
In this case.
If there's more ones, you can always just restore to the day before's.
Right. And I made a joke there about blaming Bob, but we do capture, if we were to open the full configuration and not just here on this little view of it, it would show what user made the change. Yeah. So if you're using things like TACACS where everybody's logging in, not that we're looking to point blame, but
no.
It is a learning experience.
It's a training experience.
Yes.
Everyone is going to make a mistake, hopefully not to this degree. This is obviously in the demo for a purpose, but everyone's going to make mistakes when you're learning on these things. And for me, learning networking, a little bit of a trial by fire at times. You're asked to make changes, and if you haven't gone through all the certs and you don't know the environment you're working with 100%, it's always going to be a little tricky.
You can also use this type of thing. So maybe I'm standing up a new service or a new a new entity that we're monitoring. You can set this up because one of the nice things, can you go back to where it's working?
Mm-hmm.
And go all the way to the endpoint.
You got it.
And also one of the key things that somebody will always ask, can you alert on this? Absolutely.
100%.
So
Yeah, this is not visual only.
yeah, there's out-of-the-box alerts that you can leverage when a path changes or when your latency goes over a certain percentage or when, for example, the end service may not be reachable. But go ahead and hover over the end. So one of the things I mentioned earlier, what the latency hop by hop was, here I get the total. So here it's showing me what my min, max, and average latency is for that poll cycle. So it gives me a measure of what my normal looks like.
Yeah.
So I do like that as well, especially in that scenario I mentioned where maybe I'm turning up something new and I want to see what it looks like, make sure it's working before I cut users over to it. So I have that marker, what it looked like then and what it looks like now.
I also like this when you do the switch from dev to stage and
Yes.
stage to prod, especially if you realize, oh, we sized it for 500 users simultaneously. We're anticipating, according to our market research, we're anticipating 10,000. We need to put a couple more nodes in there. And understanding how this shifts through there, and actually if you're using cloud providers that are doing this auto scale for you, see those endpoints appear and then disappear as load is just, honestly, it's just really satisfying to be able to see what they're doing on your behalf. I mean, you are paying them to do this work, so you don't have to. But I am still a little bit of a network control freak, and I like to know.
And one other thing, I don't know that we had a good example, but he mentioned some integration. So we talked about the integration with NCM, our Network Configuration Manager. We also pull some data from the NetFlow Traffic Analyzer, NTA. So if one of these internal links over here is sending NetFlow, like the one he's got highlighted here, there's your conversations. You can see some of that high-level data. So we're collecting flow on that interface so we can see what some of that net flow looks like. So,
and if one of these happens to bubble up to 50, 60, 80%, you're like, oh, whoa, 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 whoa. You can actually click on this. It'll take you over to the NTA product and actually filter automatically for this device, this interface, between this conversation for this time span.
Right.
So
do you want to go see if our cake is done out of the oven?
yeah, we'll see. So let's go ahead and hit a refresh on this. Oh, it's up and green. Now this is going to be incredibly boring, but I just want to show you how quickly and easily it can be set up. There we go, here to here. Now this I actually know, this is a lab that I operate. This is literally one machine connecting to another one. Now, this is actually a fun scenario because we see this in the world a lot. And the one I see this for, were you going to say proxy server?
I was going to say, that's actually the
Perfect.
The most common thing I've had when a customer has been setting one of these up and sees that it's not working is they get a view that looks almost identical to this. Maybe there's one or more hops at the beginning, but a lot of times it's because they have a proxy server. So maybe they're trying to test out to that NetSuite or Google or Office 365, but what's actually serving up the result, what's responding, is a proxy server within their own network. So you wouldn't get the full path. You'd see 2 or 3 hops and then you'd get an answer.
And
that is what your customers, your end users are getting.
And that's what they're supposed to get. That's why you paid to have a proxy server, to do the work for you.
So what you typically want to do, and there's usually a way to handle it either with an exclusion on the proxy device or maybe just in that probe placement I talked about earlier, you would make the exclusion so this traffic from this source box wouldn't go through the proxy. So you could see what the full path looks like and not just what the proxy server, because the proxy server, very much like that whole cloud and SaaS, it kind of obfuscates what's going on there. So, but you still need that information so you know that your proxy server may be serving the response, but if my latency to that far end device all of a sudden is up to 1,000 milliseconds,
I don't care how good your proxy server is, it's not going to be able to overcome my 1 second latency problem. We've also had people that we talked to who have either set up another machine kind of at the level of the proxy server. There's not a really but basically on the same subnet of the proxy server to behave as the probe, to basically mimic, or some people have put it directly on the proxy server. I mean, if you're already monitoring the proxy server with the agent, it just makes no reason not to do that. Just put it on there and be done.
One thing I do want to add in, because we're coming close to the end of this session, but we are answering some questions live. So if you're asking things in the chat, we do have a couple of individuals answering questions there. If anything interesting comes up, they'll bubble it up to us, and we may actually talk about it here and try to show an example. But if you do have questions, please ask those in that chat.
Yep. What else? What other scenarios? So the proxy server is one we see all the time. We don't see a lot of dark paths, but a lot of this is about peeling back the layers of your network onion that you just maybe don't know about. And for me, that's been stuff like MPLS, which I have no control over. And I don't think anyone has. Obviously if you're Verizon, that's a different thing. But if you are a regular person paying for a service, you get an IP address, you normally get an AS number, and you get an interface to connect to. And then you walk away and you trust. And that's fine. You can trust those people. And you're supposed to get change notifications and outage notifications when they change it. The difficulty with that is when you have something like that MPLS style network, and I'm going to go to a slightly different one while I set up this discussion. When you have an MPLS type network, the issue you run into is that you don't have visibility inside their hops on that layer. And the other part of that is generally the vendor doesn't have information either, because they're essentially building multiple VPN tunnels for you to transition over, so they don't see insight either. So NetPath lets you see through those things. And this is not,
But actually, can you, before you click on that,
Sure.
Go back real quick. So when he expanded that, on the right-hand side, it said 4 paths. So
I'm not clicking fast enough. My bad.
So on that basically means we've set up 4 different tests. So in this case, public-facing website. We want to know from each of these offices' perspective. So in this case, we've got a couple of data centers that we're testing from, and we have a couple of branch offices. So like I mentioned, you may be perfectly fine from New York, Chicago, LA, but all of a sudden out at your Tempe location, you've got high latency, or they can't reach it there. So that's one of the things that can give you is perspective and being able to see where the traffic is going.
Yeah, and if we talk to a lot of customers who have legacy environments where they'll have MPLS networks and they'll pay for really expensive internet pipes like at their data centers, but everything comes back to the data center before going out to the internet, understanding that latency both through your network and then out to whatever public service is incredibly important. Office 365 is an excellent example. The adoption rate on the now Microsoft 365 is insane. But if Charter Communications, and I'm sorry we're picking on Charter, it's nothing wrong with them specifically, they just happen to be here in the demo. If they make a change anywhere in here, I will get a notification if I just turn the alert on. Be like, hey, path changed. Cool. Now there's good, bad to this. The good part about this is if all of a sudden this introduces latency or some types of problem, like let's say this link that's normally 6 milliseconds, all of a sudden goes to 600, which is bad. That's bad. And 35% of my traffic's probably going over that. That's really bad. So there's either going to be a problem on this router, or maybe it's actually a cabling thing. Maybe a backhoe got involved. We're not going to say things one way or the other. But being able to actually call Charter and say, hey, this is what I'm seeing. Take a screenshot of their segment of this, send it with your case, give them the names, the IP addresses, everything. Leon has joked, I don't know if you've heard this, Leon has jokingly called this Tinder for network engineers. Yes.
Of course he did.
Because Leon. But it's because all of a sudden you have visibility inside these MPLS networks, these highly configured, highly controlled networks that even the vendor can't see because they're not supposed to see, because that's part of the way they operate with these. These engineers are like, how did you get this? Can you call me directly next time you have a problem? Because it'll take less time than flipping around and me waiting for some alert from some obscure syslog or trap or something somewhere to filter down. Being able to have this insight, and once every 10 minutes, even once every 15 minutes is probably plenty for most of these, especially for the SaaS apps.
Yeah, and one of the things that I think we touched on earlier, but we don't have an example in our demo, is potentially testing data center to data center. I want to know what it looks like from my East Coast data center to my West Coast data center to some key services, and probably vice versa. I want to know what that looks like. I've seen people use this in, maybe you have a complex Orion environment, NPM environment, testing between their pollers, because they already have agents on the pollers by default.
Yep.
It's already at the locations they want to test from,
And then they
so
can
they
use
just have it test itself, monitor the monitor.
Yeah, and you can monitor the Swiss port instead of the website because it may still be polling in the background even if the website's not behaving at that time. We've had people use this to keep up VPN tunnels. That sounds weird, but in
It's a keep alive.
it is a keep alive. So on the far side, if you need to keep a VPN tunnel up and everyone's been sent home, but you need access there, how do you fix that in today's world? You send someone to the office, you tell them to plug in a laptop and turn it on and log in, and all of a sudden the VPN tunnel gets restructured. Or you take the oldest workstation you have, you sit it in that office, you plug it directly in your switch, you put the agent on, you say probe every 10 minutes. Back to my data center. Oh, I did have a friend of mine actually talked about a scenario where you talked data center to data center. They were using CBQOS to classify their replication traffic. So it would kind of get priority between the two locations, and someone made a change to that so they could see that obviously in the network route. But the big part was the size of that link went like that because the bucket changed. So the CBQS bucket for that actual traffic changed. And thankfully, they were able to see it. And I think they said they found it the next day when they were like, why is the backup still running? Or the replication, we've never been behind that far.
So one other thing that I kind of saw that in the chat was, how does this necessarily compare to some other products out there in the market? One of the things I do want to make sure is clear is this is a built-in feature of NPM, Network Performance Monitor.
Oh, God, yeah, we always get this is not a product. You don't buy this.
Right. This is a feature of NPM. NPM is our flagship product. It's kind of how we got our start in the network space. So chances are, if you own NPM, and like Kevin said, if you're over, I think it's version 12.0 or 12.1, you have this. You just may not have used it yet, but you have this. I show this to customers all the time who don't realize they already have this functionality built into their environment. It's built-in functionality. There's no additional cost to use this module, or I'm sorry, this feature of the NPM. So as long as you have NPM, you have access to this.
Yeah, and as far as licensing count, it's incredibly low. You can put hundreds of these probes, don't need hundreds of probes. Unless you have hundreds of branch locations, which I've talked to people who run retail and put one at each of their branch locations to see if they can get back to their data center. And they just run it like every half hour just to make sure. It's still incredibly light because when you get underneath it, all we're doing is building custom TCP packets and sending a lot of them. And we're sending a large volume, but very small size. So we're not like clogging your network traffic. It also helps like right size your circuits with that NetFlow information. Say, oh, I'm using 80% on this interface on any one thing. It's like, it might be time to change those. It's also really fun when people first got sent home for this to see the split tunnel.
Give me split tunnel or give me death. One of our MVPs said that recently in a meeting we were in, and I told him
Must be a sticker.
It needs to be a sticker. I want it put on one of my tumblers.
Yeah, bumper sticker from a truck, the whole shebang.
So one quick thing, I know we are at time. We're not going to wrap this up just yet, but for those that did have a time constraint, the survey should be posted if you want to go ahead and answer those questions so that you can get your 1,000 points that we have for attending this session. Also, we do have the next one of these coming up on May 13th, which is Network Insights. But one of the things that you just mentioned to me that I wanted to come back to was when people first started working from home. So I manage a team of sales engineers. I myself am a former sales engineer and a former SolarWinds customer. Well, he has a home lab set up at his house.
Oh, yeah.
And he recently had an outage. I got a message from him saying, hey, I'm having internet issues.
And it wasn't the normal, I just want to take a day off internet?
No, it wasn't that. Yeah, I can't come in, I'm sick.
This is Chad?
This is Chad, yeah.
Okay, yeah, totally good guy.
He had sent me a picture of his net path that actually showed it. I think it went out of his home network and then died 1 or 2 hops up the stream on his provider.
Did he call the ISP?
I know his whole neighborhood, I think, called the ISPs. Okay. I think they were all down, but he had data and he showed this, and that's a real world scenario. I've done something very similar. I had it running at my house, and when my carrier had an upstream, in their case, DNS outage, it wasn't a network outage, it was DNS. my entire neighborhood was complaining about problems. Now, I don't use my carrier's DNS, no disrespect to them, but I use a different one. And I'm like, well, I'm just fine. I go pull up the NetPath, and I'm like, okay, I'm getting out.
Yeah.
And found out it was DNS, and then I let some of my neighbors know. But I did that because of this information, which these are problems we face every day. Everybody's network faces something out either internally or externally once it leaves your environment.
Mm-hmm. Yeah, I think I've used this. I always use this for user services. I mean, obviously we play in our labs, we do that kind of fun stuff, but I always like to use it for user services. The Microsoft 365s of the world, the Azure Cloudflare stuff, where to make sure if you're using those as your primary DNS, make sure you can do your DNS, make sure you can get to that from all of your branch locations, because it's easy to just throw this on a machine at each of those locations and make sure you have that everywhere. The Office 365 is a good example because this goes to outlook.office365.com, which basically is the front for what used to be Exchange or Exchange Online. And will it tell you that the services are up? No. But it will prove it's not the network that's causing the problem.
Can you scroll over to the right?
Of course.
So that's another thing here. So like you said, this one is going to outlook.office365.com. You'll notice we're actually hitting 4 separate targets at the end. Mm-hmm. Now, they're a SaaS provider. We are hitting multiple servers or multiple pods of servers that are answering these requests. I don't know those 4 IP addresses or 5 IP addresses or 10 that I'm hitting that my target. All we put in was the DNS name. Mm-hmm. So it's the NetPath itself that's figuring out that information based on the responses it gets back.
Yeah, and this is where you see the scale thing happen. It's like, oh, well, I either paying to upscale something or the SaaS, they've added more endpoints. Or what's really interesting on these is you can have this running from something in the US, US East, US West, and see a whole different set of servers on the target based on the same DNS name. That not only is incredibly powerful, especially if you have like an office or a regional based problem, but if you have the same thing international, you will contact the other clouds, depending on the name, of course, and determine whether or not it's I don't want to say nationwide, but a local issue, but on a larger scale. There's so many things you can do with NetPath, and everyone, unfortunately, just forgot they had it because we talked about it, and everyone was like, "Cool, but I don't need to buy something." And we were like, "No, you don't need to buy. You just upgrade. You'll be fine." And we're still to this day finding people who are either underusing it, and it's an incredibly powerful feature. It's low on resources. It's easy to consume. And I don't see a reason why you shouldn't be using it as many places as possible.
Yeah, like I said, it's all about visibility. And as a former network engineer and somebody who built and designed networks, I'm a big fan of that. It's not the network. Mm-hmm. So you have to have data to prove it. And, nobody just wants to hear, he's not going to say it. He's just going to say it's not him. Yeah. Well, I like to have data to prove it's not me, or prove it was Bob in the earlier example.
Yeah. And
I think the questions are slowing down in our chat. Is there any final things you want to cover, or?
Nope. I just want to remind everyone, if they're interested in the Network Insights one, it's going to be hosted on this URL again. So if you are watching us live, just go to thwack.com and look for the live cast, or you can just sit here and just keep hitting F5 on this link until it's ready. It'll be a little later this afternoon. Let's see. It's not Traceroute. It's smarter than Traceroute. It works with any TCP service. It does its own DNS check. It will also tell you if DNS failed, as opposed to whether the path failed, which is a nice distinction there.
You'll get I think it's invalid host name or host name not resolved or something like that.
All right, we covered that it's multipath aware, that it does the probing, that it's great for hybrid environments or cloud exclusive environments, how it works with VPN and now the new software-based stuff there, how it's good to keep track of your MPLS and your point-to-point people. And the only thing we didn't touch was kind of like some of the crazy math under the scenes. And that's going to be real simple. If you let us do our own calculations, and you probably should at least to get started, we will figure out the transmit likelihood and compare that to the latency and or packet loss and determine whether that's green, yellow, red. Because if you only have like a 1% transit likelihood and you're just getting like 20% or 40% packet loss, it's probably not really critical because only 1% of your traffic's ever going to possibly go over that anyway.
He calls it math. I just say it's magic, and it does it under the hood, and I don't have to worry about it. The other thing that we talked about This is a built-in feature of NPM. You likely already have it. And then if you do have some of the other modules that we mentioned, like the NetFlow Traffic Analyzer or the Network Configuration Manager, we can show some of that data in here right along the path while you're looking at it, things like config changes. So all of that is there.
I think that does it for me. I'm actually looking forward to the next one because the Network Insights is always the kind of, when we talk about peeling back the layers,
Yes.
those devices are the ones that have always been difficult to understand because they don't operate as one thing, they operate as multiple things.
Right.
And being able to understand how that works and seeing how you get information basically about all of your enterprise from a couple of clicks.
Yep.
So I guess we no more? We're good?
No, I think we're good.
So we're going to wrap. For Mike and myself, thanks for joining us, and we'll see you next time.
Stay classy, San Diego.